So we also have to be careful solving equations with radicals. And if we have an equation that looks like this, the square root of a equals b, then squaring both sides, we know that a has to be equal to b squared. And the solutions of this should include the solutions of this. However, there may be some extra solutions if there's the possibility that b might be negative. So, for example, if I take the equation the square root of a equals b, then a equals 1, b equals negative 1 satisfies the equation a equals b squared, but it's not a solution to the equation the square root of a equals b. So you may have some negative values for b popping up here on the right hand side, and you have to be a little careful about that. So again, you could follow the strategy of solving this equation and checking if the solutions on your list satisfy the original equation. In some cases you can avoid doing that because you can go backwards with the square root. So we know if the square root of a equals b, then we have a equals b squared. Now I might apply the square root to both sides here, and then I get if a equals b squared, then the square root of a is equal to the square root of b squared, which is actually the absolute value of b. So it might be plus or minus b, but if I know for sure that b is positive, then I have the original equation, the square root of a equals b. So if b here is a positive number, then the solutions to this equation are exactly the solutions to this equation. We'll look at two examples, one where the solutions to this equation are the solutions to this one, and one where they're not. So here's our first example, and you see here for an x value, b might be positive or negative, so we have to be careful. Okay, so if this is true, then squaring both sides, I get x minus 1 equals x minus 7 squared. And now this is a quadratic equation. I just have to tidy it a little bit. So this gives me that x minus 1 equals x squared minus 14x plus 7 sevens 49. And that tells me that x squared minus 14x minus that x on the left plus 49 plus the 1 on the left equals 0, or 0 equals x squared minus 15x plus 50. Now actually you can see this is a setup. There are nice factors here, namely 10 and 5, and we have 10 times 5 is 50, but we need negative numbers here because we need the sum of these to be negative 15. So the solutions to this equation are x equals 10 and x equals 5. These are solutions to this particular equation. Now, the solutions to the original equation must be on this list. So I can plug in both of these numbers into the original equation and check which ones are solutions to that. So x equals 10 in the original equation, let me call it star. That gives me the square root of 10 minus 1 equals 10 minus 7. And this is true. So x equals 10 is a solution to this equation. Now what about x equals 5? Well, let me plug it into the equation and see if it gives me equality. So I should have the square root of 5 minus 1 equals 5 minus 7. But now you see this one is not a solution because this is a negative number. So this can't happen, so that's not a solution to the original equation. So we have exactly one solution to this equation, x equals 10. On the other hand, if I take a look at this equation, I know that if this is true, then I must have x minus 1 squared plus 2x minus 4 squared equals 5. And actually, I can go back from here to here. If this happens, then the square root, that must equal to 25. That's the square of the right-hand side. But I can take the square root of both sides here because I know both sides are positive numbers. And I can go from this equation to this equation. So this is if and only if. So in other words, these two equations are equivalent. So every solution to this equation must be a solution to that one, so I should go ahead and solve this equation. Now I'm going to pull out that 2, and that's going to be 2 squared times x minus 2 squared is 25. So I got x squared minus 2x plus 1 is 4 times x squared minus 4x plus 4 equals 25. And tidying this up, this is just a quadratic. It's minus 18x, 5x squared minus 18x plus 17 minus 25 equals 0. Pardon me, that's minus 8 equals 0. Okay, I'm going to calculate this on a separate sheet of paper, so I need to find the solutions to that equation. And it's not obvious what they are, so I'm going to pull out that 5 and use the quadratic formula. Now you can see that this is not a setup. These are not very friendly numbers, but nevertheless we should be able to deal with them using our quadratic formula. So our solutions are x equals minus b, which is 18 over 5, plus or minus the square root of b squared, which is 18 squared over 25, minus 4ac, all over 2a. And the important thing here is to be brave and carry on. And this is plus or minus the square root of, I'm actually going to factor this, so this is 2 times 9 squared over 25. Minus by minus gives me a plus, 4 times 8 over 5. All over 2. And this is 18 over 5 plus or minus the square root of 4 times 81 over 25 plus 4 times, and I'm going to make this over 25, so that's 5/8, 40 over 25. And that is equal to 18 over 5 plus or minus, I'm going to pull out that 4 and the 25, so that becomes 2 over 5 times the square root of 81 plus 40, all over 2. Now that's taking this 1 over 5 out. I get that's 18 plus or minus 2 times the square root of 121 over 2 times 5. I can cancel a 2 there. That's equal to 9 plus or minus square root of 121 is 11 over 5. And that's equal to either 9 plus 11, 20 over 5, or 9 minus 11, which is minus 2 over 5. So I have two solutions, x equals 4 here, or x equals minus 2 over 5. Now both of those solutions are solutions to this equation, but I claim that any solution to this equation must be a solution to this equation because I can get from here to here by taking square roots. I cannot do this in this example because the square root of the right-hand side here is the absolute value of x minus 7, so there's a possibility of a negative number happening there. So both of these give me solutions to the original equation. If you're a little uncomfortable with this going back, you can just check both of these solutions and you'll find that they're solutions to your original equation.